Today let's talk about how to calculate oxidation number of elements in a compound. So we are going to be looking at certain rules for calculating oxidation number. Let's pick them one after the other. So the first rule is that the sum of the oxidation number the sum of the oxidation number of elements in a compound is equal to 0. So what that means is that all the elements that you have in H2SO4, if you add the oxidation number of all the elements together, it's going to be equal to 0. Let's look at the second rule. The oxidation number or combining power of an element is the number of electrons it will lose or gain to attain octet or duplet valence. So when you have an element in a compound, the oxidation number of each element in that compound is what I've defined. It is the number of electrons that that element will gain or lose to attain stability. For example, sodium has atomic number 11. If you write the configuration, it is 281. So for example, sodium, the configuration is 281. So it needs to give out to lose this one electron, alright, to attain octet valence. Valency means the number of electrons in the outermost shell. Octet means 8. Duplet means 2. So to have 8 electrons in the outermost shell, it means to give out 1. And when it loses 1 electron, that is plus 1. So the oxidation number of sodium will be plus 1. Right? So plus 1. That's the oxidation number of sodium. While for chlorine is number 17. If you write the configuration 287, this chlorine needs 1 electron to attain octet valency or stability. So it will borrow 1 electron, and that is the number of, that will be the oxidation number, -1. So the oxidation number of chlorine is -1. Let's look at the next rule, number 3. The sum of oxidation number of elements or group of elements in an ion is equal to the charge it carries. So for example, if I have SO42 minus, the sum of all the oxidation number of elements in this ion is equal to -2. Are you with me? If I have Cl minus, this is a group of elements. This is just one element. The oxidation number is -1. Is that okay? So if I have CO32 minus, the sum of the oxidation number will be minus 2. Let's look at the next rule. So the next rule says, so this rule says when you have two electronegative elements in a compound, the more electronegative of the two elements, okay, carries its negative oxidation number, while the other will carry positive. So you cannot have two negatives coming together. Remember, like poles repel and like poles attract. So when you have two elements, so for example, sulfur and oxygen, they are both highly electronegative elements. In this situation, the most electronegative of the two will come in with its negative oxidation number, while the least electronegative will come in with a positive. So in this case, the oxidation number of oxygen here, because oxygen is more electronegative, so it comes in with oxidation number of minus 2. Sulfur cannot come in with minus 2. Rather, sulfur will come in with a positive oxidation number, which is plus 6. Alright, so that is that. That is the fourth rule. So when you want to calculate the oxidation number of the unknown element is represented with X. So let's see some examples. If you are asked to calculate the oxidation number of sulfur in H2SO4. Oxidation number of sulfur. Now, can you see this is a compound, so the sum of all the oxidation number here will be equal to 0, and then you represent this unknown with X. So what will be the oxidation number of hydrogen? From the definition, we said the oxidation number of an element in a compound is the number of electrons it will lose or gain to attain stability. Hydrogen will give out one electron, right, when it ionizes, so it is plus 1. So hydrogen is 1 plus 1, but there are 2 moles of hydrogen in this compound, so 1 times 2 plus, we represent this unknown with X. Oxygen is minus 2 because it will borrow 2 electrons to attain stability, times 4, all will be equal to 0. 2 plus X minus 8 equals 0. 2 minus 8 is minus 6. X minus 6 equals 0, then X will equal to plus 6. So that is the oxidation number of sulfur here, and that is why this compound is called tetraoxosulfate 6 acid. Tetraoxosulfate 6 acid. Can you see the 6? That means the oxidation number of sulfur in this compound is 6. Is that clear? Let's look at another example. K2CrO2O7. You are asked to find the oxidation number of chromium in K2CrO2O7. So you have potassium is in group 1, right? If you have not seen the video on periodic table, please just check for the video in our channel. Potassium is in group 1, therefore it has oxidation number of 1. It's plus 1. So you have 2 times 1 plus, this is unknown, so you represent it with X, but there are 2 moles of chromium here. So you have 2X plus, oxygen is always minus 2 multiplied by 7, minus 2 times 7. All will be equal to 7. So you have 2 plus 2X minus 14 equals 0. 2 minus 14 is minus 12. So 2X minus 12 equals 0. So 2X will be equal to minus 12 crosses becomes 12. Divide both sides by 2. Your X is equal to 6. So this is potassium heptaoxo dichromate 6. So the oxidation number of chromium here is 6. Now let's pick one more example using an ale. After that, I'm going to give you 3 questions as your quiz. Alright, you can just, once you have answered the question, give me the answers at the comment section so I can be sure that you understood the topic. So let's look at the third one. If you are asked to find the oxidation number of sulfur in SO4, okay, you were asked to find the oxidation number of sulfur in SO4 2 minus. So what you do is, you represent this with x, so you have x plus, oxygen is minus 2 times 4, all will be equal to minus 2. Alright? Then you have x minus 8 equals minus 2. This crosses here, your x is equals to 8 minus 2. X equals to 6. Therefore, the oxidation number of sulfur here is plus 6. So let me give you this quiz, these questions for your quiz. Number 1, you have to find the oxidation number of the underlined element, okay? Oxidation number of manganese in KMnO4. Then oxidation number of carbon in CO3 2 minus. And the third one is you have to find the oxidation number of nitrogen in HNO3. Alright, so I'll be expecting your response to the question in the comment section. Thank you for joining us in the class today. My name is Coach Paul, and I believe you enjoyed the class. Do well to share the video with your friends, and if you have not subscribed to our channel, do well to hit the subscribe button right now. Okay? And see you in the next class. Thank you. Bye for now.